Substitution reactions. Carbon can make four very strong covalent bonds. And if it has four, it's a saturated compound. Saturated compounds are very stable. Often, catalysts are required to make a reaction go because they're so stable. Often, more than one product can be formed. So often, to get a product, you use a different chemical reaction other than substitution if you're going for a specific product, because there's many different products that you can get. If you do use a catalyst, to represent your catalyst, you put them over or below the arrow in your chemical reaction. Sometimes you'll just represent it by a letter. This O in square bracket means oxidizer. Sometimes it's specified as an actual chemical compound, like a strong acid, but it's always put above or below the arrow. In a substitution reaction, a hydrogen atom is replaced by another atom or group of atoms. You can also have one functional group replaced by another functional group. So alkanes and benzene are very stable. Therefore, they need catalysts for substitution. An example of a substitution, you can have an alkane and you can add a halogen to it. So you react it with the molecule of your halogen, and you end up with a haloalkane plus a molecule of a hydrohalogen. Often we use UV light as the catalyst, and you can get many different structural isomers. It's hard to predict where the halogen is going to add. So for instance, if we have ethane, and we want to add a chlorine atom, we would get, amongst many other possibilities, chloroethane and hydrogen chloride. If you want to put more chlorines on, you would have to have an excess of chlorine molecules. To represent that, if you want to add another chlorine, you would put a coefficient of 2 in front, and you would add another chlorine somewhere. It could go on the same atom, or same carbon atom, possibly the other chlorine atom, and you would make two molecules of hydrogen chloride, but it's so hard to predict what actually will happen. So benzene plus a halogen will make a halobenzene plus a hydrogen halide. For example, benzene plus bromine will make bromobenzene and hydrogen bromide. Only one halogen atom is bonded per molecule of halogen, just like for the alkanes. You can also convert an alcohol to a haloalkane by reacting it with a hydrogen halide and your other product is water. You form a water molecule. So what happens here, let's take ethanol as an example. If you react ethanol with a hydrogen halide, you end up substituting this OH group with the halogen, and the H from the hydrohalogen joins with the hydroxyl group and forms your water molecule. And so your halogen substitutes for that hydroxyl group, and you get your haloalkane. If we had used hydrogen chloride, we would end up with chloroethane and water. We can also reverse this. We can take a haloalkane, add a hydroxide, and this will make an alcohol and a halide ion. So we could have our chloroethane, add a source of hydroxide ions, and we would make ethanol and chloride ions.